Assalamualaikum and hi everyone. My name is SYAHIDA and today I would like to present about the strategy to perform a material selection. In this assignment, the part of shrink that is selected is the barrel. What is barrel? The barrel is the part of the hypodermic needle that contains the material that is injected. There are 4 steps of strategy to perform material selection of a barrel. The first one is translation, the second one is screening using constraint, the third one is ranking using objective, and the fourth one is documentation. Step 1. Translation and deriving performance index. Function. Like stiff barrel. To withstand the pressure and allowing the shrink to take in and expel liquid or gas through a discharge orifice at the front, which is open end of the tube. The objective is maximize the toughness and minimize the miss. And the constraint is optical transparency and adequate fracture toughness, which is able to be molded. The process is plastic injection molding. And the free variables are choice of material. The weight of material can be minimized by selecting the subset of materials with the greatest value of M. The Young modulus is plotted against the density on the log scale. For the part selected, the material performance index is calculated. Then the log is taken and rearrange the equation into a form of y equal to mx plus c. Hence, the slope is calculated as below. Then, a slope of 2 is calculated and inserted into the material property chart. Figures show that there are about 41 material candidates shown in the result. Step 2 is screening. Attribute limit is set and index is adjusted for polypropylene by inserting the attribute limits into the formula. After applying the attribute limits, the material candidates have reduced from 41 to only 2. The material that can be considered are polypropylene and cellulose polymers. Step 3 is ranking. The material properties of the 2 material candidates are listed according to the design requirements. Table below shown the material properties for the selected candidates, which are performance index, Young modulus, density, moldability, cost, and lastly the comments. The comments of polypropylene is low in density, high moldability, and low expensive. But the cellulose polymer have high density, low moldability, and expensive. The specification of polypropylene medical grade is that the polypropylene medical grade is transparent homopolymer that features flowability and balanced mechanical properties suitable for injection molding application for manufacturing hypodermic sterile plastic shrinks. And the last step is documentation. Throughout the 4 steps, the polypropylene PP is selected due to the design requirements, which are high modulus, which is high stiffness, low density, high moldability, and low cost, and it meets all the design requirements. Stiffness can be thought of as a function of the product of Young's modulus and the thickness raised to the 3rd power. Next, low density is a high clarity and chemicality inert polymer that is widely used, owing to its flexibility, barrier properties, good impact strength, and stress crack resistance. Moreover, polypropylene is inexpensive and costs only 5.7 ringgit per kilogram, and the goal of any new product introduction is to meet customers' needs with a quality product at the lowest possible cost in order to return the highest level of profit. Polypropylene also has high flexural strength due to its semi-crystalline nature and a relatively slippery surface. Thank you.
Assalamualaikum and good day everyone. My name is Muhammad ZAFRI and I'm going to talk about the process for polypropylene PP. So generally in this production we are using the injection molding process So what is injection molding process? So basically, injection molding of thermoplastics is equivalent of pressure die casting of metals. So it has a reciprocating screw machine system involved in the machine. So this is where the screw is at. And so there are some procedures in making the syringe barrel using injection molding. So barrels are formed through mold installed in the injection machine with hot melt polypropylene. So the first step is raw polypropylene material in the form of granules or tiny pellets, and then it is fed through a hopper and melted at a high heat. Polypropylene material is then injected under pressure into a single mold to produce the desired barrel shape that we wanted to have. And then polypropylene parts with barrel shape are then left to cool down. And the last one is injection mold is opened up and the new polypropylene material component is released in the machine to repeat the process. So basically this is a figure of how the machine works. So this is where the granules of polypropylene materials are inserted and then it will go into the machine. So this is the screw system that move the material. So this is the part that there is a part of in the machine that melted the polypropylene from granules into a kind of liquid in the liquid form, and then it is injected into a mold of the shape that we wanted, and then it is left to cool, and a product is being produced. So the machine uses a motor to move the screw as a way of moving the material in the machine. So there are some process parameters for injection molding. So the first one, we're going to look at the material. So our material used in this process is polypropylene PP material, which is very suitable to be used for the process. This is because of polypropylene material can be molded and then the shape desired. So a barrel shape is basically a circular shape and it can be molded through the process. So it fits the process, the requirement for injection molding process. And then the tool cost. Tool cost is quite high, but depending on the production rate. It means that the higher we produce, the higher products that we produce, the more affordable cost it will be. And then the equipment cost, it is same as the tool cost, which is high, but depending on the production rate. But the thing is, labor intensity is low. So this is the good part. And it has tolerance of 0.07 to 1 mm. And then roughness of 0.2 to 1.6 micrometer. And surface roughness. So surface roughness is an important aspect of the product. So material product will have a very smooth surface roughness, and it is good for a syringe barrel. It is because syringe barrel is used to insert liquid into it. So after using it, there will be no residue in it due to a very smooth surface roughness. And then the relative cost index is between 64 to 191 Malaysian ringgit, which is depending on the production rate. The higher production rate, the more affordable cost it will be. And then the material utilization fraction is between 0.6 to 0.9, which is good. And it have a long tool life. So those are the parameters for injection molding. And that is all from me. Thank you.
Good morning, Doctor. Now I'm going to present you about the flowchart of production process. First, we must prepare the raw materials and feed through the hopper. In the hopper, it will melt in a high heat and it was injected into the single mold. After injected, it was cooled down and released. After that, it was sent to the printing section to print the measurement label on the barrel. After printing section, it was sent to the assemble part to assemble all the parts of syringe, and it was sent to the packaging section. After we pack the syringe hall, it was sent to the sterilization section, and lastly it was kept in the warehouse. So this was the flow chart of producing the barrel. Okay, now we're going to see the description of each process. Basically, injection molding is where the machine received the granule injection molding material from the ethanol source, and it was melted and injected to the single mold. The next process is printing process. The label printed on the barrel according to the accurate units. These labels provide or used to measure the volume. Beside that, the next process was assemble part. At the assemble part, we combine all the parts for produce a syringe, for example, like needle, gasset, and moreover. In the packaging process, we will pack all the syringe in an airtight wrap and seal it with carefully. The next process was sterilization, where the ETO sterilizer was sterilizing the syringe in the cabinet with the ethyl oxide gas. It was done for all the medical production that is not suitable for conventional. And the last process was at warehouse, where we keep all the syringe which was packed in the warehouse. So that's all from me. Thank you.
Hello, my name is NURRAHASSIKEN KASIM. I'm going to explain the manufacturing process selection strategy. Process selection needs to undergo 4 different stages, which is translation, screening, ranking, and documentation. So for the first stages, we need to do the translation, which is we need to define the functions, constraints, objectives, and free variables of the barrel's range. Functions of the barrel's range is able to shape the barrel. So the constraint is 3D hollow for the shape, and the material is polypropylene. The volume needs to be 5 milliliter, and the weight must be less than 250 grams. So for the objectives is we observe to minimize cost and minimize weight. For the free variables is we are free to choose any kind of process. So for the next step is screening. Screening defines to eliminate the processes that cannot meet the constraints that have been made from the translation. So to establish the screening process, we do the process selection based on 3 different charts, which is the first one is process material chart, the second one is process mass chart, and the third one is process shape chart. After the screening process, we found 8 processes listed suitable for the process for the syringe barrels, which is conventional molding, injection molding, blow molding, compression molding, rotational molding, thermoforming, polymer casting, and lastly is resin transfer molding. So for the next step is ranking. After listed to the 8 most suitable process during screening stage, we need to compare between those processes. During ranking process, we compare the relative cost, capital cost, tooling cost, and economics description of those processes. And it is observed that injection molding has the lowest relative cost, capital cost, tooling cost, and the best description for economics. Lastly, on documentation stage, we choose injection molding for the most suitable process to create a syringe barrel. This is because injection molding fulfill all the translations requirement because it can produce cylindrical shape and is lightweight of 250 grams. And the relative cost for injection molding is just from 64 ringgit until 191 ringgit. Next, I will also be explaining on the effects on parameters for the syringe barrel. Effects on the chosen material, which is polypropylene. Polypropylene is latex-free and contains no rubber or silicone, so it is safe for medical use. Next is shape desired. Syringe is a cylindrical shape because it works in atmospheric pressure physically. That's all from me. Thank you.
Assalamualaikum and hi everyone. My name is Khairunnajwa binti Nazzil SYAHIDA. Today I would like to present for the testing and quality control, types of defects and countermeasure, and lastly for the conclusion. There is 4 test methods. The first is the dimensional measurements. We take the dimension for the barrel, the inner and outer diameter, length and finger flange, stopper and plunger, label and graduation line spacing. Secondly is the performance. We test for the glide force, brake force, dead space, burst, accuracy, injection force, piston, seal blowback, spray pattern and leakage. Thirdly, the component compatibility. We test for the ease of assembly, leakage, stress, cracking, separation force, unscrewing top, coring needle test, anti-needle stick, safety needle, mechanism, tip cap removal force, assessment of compatibility with intended devices, connection incompatibility with inappropriate devices. And lastly is the integrity. During the test method, it is important to have the visual inspection, dye penetration, blister seal strength, gross leakage, bubble emission, and pressure leaking. And next, the common testing measurements. Basically, the common testing measurements is the breakaway force measures the initial peak force required to begin plunger movement. Secondly, the glide force is the force required to keep it moving to continue depressing the plunger. Thirdly, the liquid leakage of the plunger is also important. And lastly is the plunger performance is a measure of the minimum, the maximum and mean forces needed during the plunger stroke. After the test method, the shrink have to go through for the sterilization process. The purpose is for the elimination of all live organism, bacteria and fungi spores from the contents of a product. There is two types of the sterilization for the shrink. The first is the EO sterilization. EO is the ethylene oxide. This is suitable for heat-sensitive and moisture-sensitive materials. And pure EO gas is flammable and explosive, so EO gas is reacted with some agents like hydrochlorofluorocarbon, HCFC, and carbon dioxide. And secondly is the ionized radiation, which uses gamma rays or E-beam. Next, we move to the types of defects and countermeasure. There is 11 types of defects. The firstly is the under-injection, which caused by the improper control of process conditions, and the countermeasure, it should be adjusted appropriately. Secondly, the injection capacity of injection molding machine is less than the weight of plastic parts. And the countermeasure is the injection molding machine with larger specifications should be used. Secondly, the defects is the overflow flash caused by the insufficient clamping force, and the countermeasure is the injection molding machine with larger specifications should be used. Secondly, the pinhole or guide pin of the mold is seriously worn. and the countermeasure is repair shall be done by machining. Next, the surface porosity, caused by when the size of runner end gate of thick wall plastic parts is small, it is easy to produce surface pores, and the countermeasure is the size of runner end gate should be enlarged properly. Secondly, the wall of the plastic part is too thick, and the countermeasure is the wall thickness should be reduced as much as possible in the design. And next, the flow mark. The cause is the melting material and mold temperature are too low. The countermeasure, the barrel and mold temperature should be appropriately high. And the secondly is the injection speed is too slow, and the countermeasure is the injection speed should be increased appropriately. Then the silver streaking, caused by the content of moisture and volatile matter in raw materials is too high, and the countermeasure is the raw materials should be pre-dried. Secondly, the exhaust of mold is poor, and the countermeasure is the exhaust hole should be added to improve the exhaust performance of the mold. The sixth is the weld line. The cause is the temperature of melting material and mold is too low, and the countermeasure is the barrel and mold temperature should be increased. Secondly, the gate location is unreasonable, and the countermeasure is the gate position should be changed. Next, the bubbles, caused by the size of gate and runner is too small, and the countermeasure is it should be increased appropriately. Next, the injection pressure is too low, and it should be raised appropriately. Then, the cracking and whitening, caused by the temperature of melting material and mold is too low, and the countermeasure is the barrel and mold temperature should be increased. The second cause is the structural design of the gating system is unreasonable, and the countermeasure is the structure of runner and gate should be improved to avoid turbulence during filling. Then the bending deformation. The cause is mold temperature is too high or insufficient cooling. The countermeasure is the mold temperature should be reduced or the cooling time should be prolonged. Next, the uneven cooling, and the countermeasure is the cooling system of the mold should be improved. Last but not least, the shrinkage deformation. The cause is insufficient injection pressure, and the countermeasure is it should be raised appropriately. And secondly, the mold temperature is too high, it should be reduced appropriately. Lastly, the vacuum hole. The cause is insufficient pressure holding, and the countermeasure is the injection time should be prolonged. The mold temperature is too low, barrel temperature is too high, and the countermeasure is the mold temperature should be increased properly to reduce the barrel temperature. Finally, we move to the conclusion. Throughout this study, we have explained ideas relevant to material selection analysis in product design and manufacturing. The chosen part in our study is the barrel. We relate the ideas to the selection of process and material using the CES Edupack software by utilizing materials, properties, charts, and data. After going through the material selection process, which includes translating, screening, ranking, and documentation, the material that meets the required properties of the barrel is polypropylene, PP. Polypropylene is the material of choice in medical applications, not only because of its lightweight, low cost, but also due to high chemical and bacterial resistance. The manufacturing process involved is injection molding. There are 11 types of defects that can occur in polypropylene injection molding. To identify the defects, several tests can be conducted. The common hypodermic shrink testing measurements are breakaway force, glide force, liquid leakage, and plunger performance. Next, the plastic syringe, which are classified as Class IA medical devices. Materials used in the production of plastic syringe must be at medical grade. As a result, hypodermic syringe, which are the most frequently used ones and made of PP or PE, take place under the umbrella of Class AA medical devices. And they have to own several properties indicated in pharmacopoeias, suitable process of production indicated in standards, and pass the tests which are applied to plastic material after the radiation sterilization. That's all from me and from us. Thank you.